Hi guys, and welcome back to the channel. In this week's video, we're going to be running through one of the most comprehensive quick starts on the Snowflake website available to you. And we're going to include Snowflake Marketplace data. We're going to leverage Cortex LLMs. We're going to use the latest geospatial mapping available within Snowflake natively. And we're also going to visualize all of this on the Streamlit application using the power of Cortex. So I hope you find this video useful. Let's get straight into things. Did you know that 2/3 of Snowflake customers capture the latitude and longitude data in their account of certain places? And the disappointing thing is that most organizations are only using this for basic mapping, and there's a lot of untapped potential that I'm going to uncover with you guys today in this short video. And what we're going to use is a hexagon. So why does the world need a hexagon? So first, we've got traditional shapes. So think about country borders, state boundaries, or postal codes. They're irregular shapes, and that requires complex calculations. So that means they perform slowly, they take up a lot of storage space, and they're difficult to work with at scale. But hexagons solve all of these problems. Each hexagon has 6 equal neighbors. That means every calculation is consistent and predictable, and that helps our queries be lightning fast. And this transformation isn't just theoretical. Companies across lots of different industries are already using this. Telecoms are using it to monitor network performance across these hexagon grids. Insurance companies use it to analyze risk patterns in different geographies and flooding risks, for example. Whereas logistics use it to optimize delivery routes. And retailers are making supply chain decisions, all because hexagons make spatial analysis fast and reliable. And so this is where AI meets geography with Snowflake Cortex. Now, traditionally, you're using static tooltips. It's a lot of manual, user-intensive activity to generate analysis and insights. Whereas today, we can use an AI-enhanced approach. And this is what you're going to discover in today's hands-on lab. It's going to cover smart descriptions. We're going to look at how we can leverage AI to create emails for us based upon this geospatial data, and look at different patterns that the data is telling us. So in today's lab, we're going to look at using UK location data. We're actually going to use the A3 spatial indexing that Snowflake provides out of the box, as well as some native geography and JSON flattened functions. We're also then going to use the Cortex suite of LLMs along with Snowpark to generate intelligent descriptions for our tooltips and generate data from location patterns. We're then going to build interactive Streamlit app to visualize where train stations are and overlay different points of interest. We're going to use the Snowflake Marketplace. So we're going to just point and click and get data and bring Northern Trains data and Overture Maps data in there so we can add these as layers on our maps. And then we're going to bring together notebooks with Streamlit to bring it all together for presentation in one unified platform, which is of course Snowflake. So let's get into it. So here we are in our Snowflake environment. I've went into projects, worksheets, and created a new worksheet. In here, I'm going to run the first step, which is the initial setup, and we're going to create the objects that we need to run this quick start. So we're going to create a database, a couple of schemas in there, and a particular warehouse, granting the privileges on the warehouse and on the database to the account admin role. And then this is optional depending on which region your Snowflake account you're using is situated in. You may not be able to access all of the Cortex functions that we're going to use in this quick start. So just to make sure we can run this anyway, and that allows you to enable the Cortex services cross-region. Let's execute that and create our objects. Okay, so the next thing that we're going to do is we're going to get the data sets that we need to run our quick start. And to do that, we're going to go down to data products and we're going to go to the Snowflake Marketplace. Now, if you haven't used the Snowflake Marketplace before, it has a whole bunch of free and paid for data sets, which are updated by third parties and made available for you to bring into your Snowflake environment in a really easy and seamless way. We're going to go to the search bar here and we're going to bring in Northern Train Station data. So if we search for that, this is what comes up. It's provided by Northern Trains and it gives us station specific data. So if we click into there and we can see an example of what the data looks like. So we've got a code that represents the station name, the postcode of where it's situated, as well as the longitude and latitude. Simple table with an example of how we can use it. I've already got this in my environment. If you're coming here for the first time, you just click Get Data. Don't change the database name from the default, and that will make that available within your environment. To double check that, you can come down to Data, Databases, and you will be able to see Northern Trains station data in your environment. And if we go now back into Marketplace, we are going to get Overture Maps data. So this is the one that we want, provided by Carto. And this gives us a representation of facilities, services, businesses, and amenities. Again, I've already got this in part of my environment. You can click Get, don't change the database name, and that will make it available. So now we're going to go to our notebook in Snowflake, and we're going to go Projects, Notebook. Now in here, we can click the blue button to create a brand new notebook, or we can click this little drop down here and import a file. And you can do the same by downloading the file, same file from GitHub, using the link in the video description below. So the first thing is I'm going to title this notebook UK Analytics. The database, I'm going to use the Build UK database we created earlier, and the notebook schema. And the query warehouse, I'm going to change to the Build UK warehouse. Leave everything else the same and click Create. Now before we start this notebook, we need to add some packages that we're going to reference in our Python code. If we click this packages drop down, we're going to add PyDeck, which is what we need to render the maps. And if we click Start, we'll start the notebook up. Okay, so after a couple of moments, our notebook is now active and running. We want to make sure that the public role is added to the data sets that we've brought in from the marketplace. So we're going to execute that cell and just make sure that the public role can access the data. Now we're going to create the first map layer. So this cell actually imports some of the Python packages that we're going to use, including Snowpark and Streamlit. Streamlit, if you don't know, is an interactive web application built upon Python code, which makes it really easy to create interactive applications without the need to know HTML and CSS and so on. So let's run this cell, and down below here you can see then we've got our title, UK Analytics within the north of England, and then the picture of a train, and then this app shows the key insights of places, etc. So we've added a title and we've written out a bit of text code there, and this is our Streamlit application, or the start of it anyway. And now we're going to start to use some of the data that we've brought in from the marketplace, starting with the Northern Trains station data. So notice here then we bring it in and reference it right here. And if we run this piece of code, that data within the Northern Train station table. And if we scroll down a bit more, we're able to map those stations onto a map of the UK, like so. If I scroll back up just to show you how easy that is, it's st.map, so the Streamlit function, and we're passing in the data set and telling Streamlit which columns to use for longitude and latitude, which are these ones, and we've got them placed on a map. Simple as that. We can zoom in and zoom out on that, but that's as interesting as it gets at this stage. So now we want to create a boundary box, so think of that is a box around the places that we're interested in. And so to do that, we're going to run this cell because we want to filter this data set to only list the places of interest that we're interested in the Northern Trains locality. And we're going to overlay the Carto Overture maps, which shows facilities within a particular location. So now we've created 5 sets of coordinates in order to draw out this boundary box. So now we're going to find the center point of the map because we're going to render from that location. We're going to transform that into long and latitude variables and store them here. And then we're going to transform the data in this pandas dataset so that the PyDeck visualization tool can view it as a polygon. Then we'll create the layer so we can visualize it on a map and render the map at the last point so we can actually view that. So let's run this cell and see what we get back. Here we go. We've got our map rendered with our boundary box in the area of interest that we want to focus in on. That allows us to filter the data more effectively when we want to overlay other layers from our other data sets that we've got. Let's now move on to that and look at the Overture Maps Places Carto data set. We're going to filter this based upon our boundary box that we've created as well. So let's run this cell. We get a lot of semi-structured JSON data being returned. And we're going to use Snowflake's out-of-the-box native capability to query semi-structured data to extract the elements that we're interested in. So let's do that next. And by running this, we'll get that data set back in a more readable format. We've been able to shred that JSON data really easily into individual columns where we've got different categories of places, so restaurants, travel services, hotels, etc., the website of them, and crucially, we have the coordinates of where they are, longitude and latitude coordinates within this geometry field that we're going to use in a second. Next, we're going to filter the categories for just all restaurants. And if we execute this, we will write out all of the longitude and latitudes for restaurants from the data set only. So we're filtering the places. Okay, now we have it. We filtered the data set now by restaurants, and we're returning the same data back. We're now going to use that data set and we're going to plot that on our map. So what we're going to do here is we are going to visualize these restaurants on our map using the same boundary box as we created before. And we're also adding in tooltips. So we've got the place name and the alternate name for that particular place using this piece of code here. And we can zoom in. So again, now we've mapped our restaurants within our boundary box and added a tooltip. Let's move to the next stage. We're going to create another layer which shows the train stations now provided by our Northern Trains data set. We've got our train stations, which are the ones in blue, and we've got our restaurants in white. So we've overlaid a couple of layers within our boundary box now. Now this is where we're going to introduce Snowflake Cortex. We're going to use this to give us descriptive tooltips by using the train station attributes. So let's execute this cell next. Okay, so now we've got the station footfall, if there's car parking spaces, if there's cycle storage, the number of bus stops within 1 kilometer of the train station, and even the local MP's position and email address of them as well. We're going to use that a little later in this quick start. We don't need to worry too much about it for now. So wouldn't it be great if we could take this detailed information and pass it into an LLM to bring back some data that we can actually import into our tooltip to make it more user-friendly. So that's exactly what we're going to do next. And here we're picking up our data that we've just looked at from the table. We're giving it a prompt. In less than 200 words, write a summary based upon the following train station details. We're giving it a bit of context in terms of telling the LLM where the train stations are based, and only include the Northern train station names in the descriptions. Write in the best way for it to describe a point on a map. So let's execute this and see what we're getting from a tooltip perspective, leveraging the Cortex LLMs. Now remember, this data doesn't go outside of your Snowflake environment. It's all ran inside of Snowflake. It's going to pass in that prompt. It's going to populate that with our data that we're also getting from our Northern Trains data set. And we're using Mistral Large in this case. So this is where we're specifying our model as part of the call function, and we're using the complete function, which allows and tells the LLM that we're picking to complete and respond to the prompt that we're providing it with. You can then see that we're actually overwriting the data within this table, data.trainstation information. So we're writing it back into our Snowflake database. And then we're returning that back to the result set just for the first 5 records. So we've got the alternate description here. You can see that we're getting a much more detailed description. It tells us that Beswick Station is an unstaffed Northern train station which sees a footfall of 572 passengers, doesn't offer car parking spaces, and the station is represented by Labour MP Ashley Dalton. So you can see now instantly how this is offering a much more user-friendly and descriptive tooltip that we can now use on our map. So we're going to bring this in and add it to our map as a tooltip. So let's run this cell. So here's our boundary box again with our train stations and restaurants on here. Now if we go to One of the green ones, which represents the train stations, here's our enhanced tooltips that we're now getting back. Notice our restaurants are still there, again for some basic information against it. But isn't that a great way of being able to leverage Cortex really easily and simply to enhance our user experience? Now we're going to take it one step further and we're going to use Cortex to list out any key location events. So we're going to try to work out if there's any key event happening within our boundary box, within the north of England, and how the restaurants and train stations may be impacted around this. So we don't have any specific event data. We're actually going to use Snowflake Cortex and Snowflake's native Arctic LLM model to suggest what events may impact this area. Now, it's not a live data repository, so it's not going to have up-to-date information in here, but it does use historical data. And here's our prompt: retrieve 6 events within different cities of the north of England that will happen in 2024. Do not include commentary and notes. Retrieve this in the following JSON format. So we're going to retrieve it in the JSON format, so then we can actually use it effectively to layer onto our map. Once we get that data back in JSON format, once again, we'll use Snowflake's native tools to be able to translate that semi-structured data into a relational data frame, and we can then add that onto our map. Notice that the JSON format that we're giving it, we're telling it to populate a date, give us the description of what the event is, and giving us the longitude and latitude. And this is obviously really important because this will allow us to overlay these key location events on the map. Now that might take a while to run. For me, on a extra small warehouse, it took 4 minutes, and this is what we get back. Now I've just downloaded that into a CSV using this button here. You don't need to do this, but I just wanted to show you what was returned in here. So here's our 6 records. We've got Leeds Festival of Light, Manchester Beer Festival, Liverpool Food and Drink Festival, and so on. We've got our coordinates, a little description, and that's everything that we need now to be able to flatten that using Snowflake's native functions, which we'll do next in here. So we're going to flatten that JSON, map it into a data set, a tabular data set here, and we're going to use H3. Now, if you don't know what H3 is, it's basically hexagons developed originally by Uber, and every hexagon basically joins to the next one, and everything has a unique index, and it makes it much easier, simpler, and less computational intensive to work with geospatial data. Let's execute this, and we're going to call this H3 point to cell string function. And this is what it gives us back in this H3 column. We're now going to use that to map these events as another layer onto our map. And here we go, get hexagon, H3. We'll bring it in as an H3 hexagon layer onto our map, making it really easy to work with this data. So here's our H3 location for each of the events with our description. If we scroll down, we can now clearly see these events highlighted as these individual hexagons, these H3 hexagons on our map. So again, we've got our original, if I go zoom right into here, we've got our original restaurant name in white. We've got our Cortex enhanced description for our train stations. And now we've got these hotspots of events overlaid as another layer on our map, so we can see what restaurants and train stations are going to be impacted by these particular events which are happening in the area within our boundary box. Now we're going to update this data set to look at just those impacted areas. So to do that, we're going to enjoin the events data to the train stations data frame and enjoin that events data frame to the restaurants data frame. So here we are. So here's a H3 hexagon area here. These top 3 records all relate to the same one. Here's our restaurants which are impacted by an event. If we scroll to the right hand side, we can see that the Leeds Festival of Light event is impacting these particular restaurants because it's in the same vicinity based upon our H3 hexagon. Now we've got this together, we want to use Cortex again, and this time because we've got the MP details and the email address, we are going to use that to write an email to send to the local MPs to let them know about these events which are coming up in their area. So to do that, we're going to create an object which links those affected restaurants to the relevant MP. And we're also calculating here the distance from each event to the restaurant. Here's our data set. We've got our MP address, And then we've got a JSON record, which has the details in here, including the distance from event, as well as the phone number and website further along in that JSON record. So next up, we're going to create another object that links the train stations, which are impacted by these events, to the relevant MP, which we've got here. And now we're going to bring the events in, which are here. And then we're going to bring everything together. So we're going to join all those objects together into one data set. So that's the events and who's affected and the relevant MP. All right, so we've brought all the data together. So MP, train stations, events, the restaurants, and the MP's email address. Now we're getting closer to be able to generate a correspondence email. I'm just going to reduce the data set slightly by filtering these records out, just to pick up the first 8 records for each MP. And then we're going to create the prompt for LLM. We're providing a name, an email address, who it's going to come from, title of the email, and the style that we want the LLM to use. And here we're building up our prompt. So write an email address to this MP in the style of a worried resident, in this case, about the particular events that we're passing in, affecting the train stations and these restaurants. The letter is written by the name, email address, and title. So if we build up our prompt, so here we go, name, email, title, style. Notice that we're using Streamlit here as a text input box, so we can actually update these to whatever we want. Let's just leave it as is though. Now we're going to go to our Cortex complete function again, using the actual model that we specified. In this case, we're using this Mistral model. And we are going to pass our prompt in, and that's going to save our letters to this table, data letters to MP, back into Snowflake. Now let's have a look at the data set that we've just saved. So here we go. Got an MP name, our MP email address, and then the actual letter itself. So the subject, hard to read in this format. So down here, we're going to use Streamlit functions again to actually let us look at the individual letters. So we've got this little slider that lets us scan through all of the letters that's created. You can see we've got the email address of the MP, the subject itself, and the actual email in the style that we wanted it to be produced in. And it's even going to the extent of proposing some measures, such as increase in parking facilities at the station for the additional influx of visitors. So such a great way to be able to leverage Cortex LLMs and geospatial data sets, as well as Snowflake data available in the marketplace. I hope you found that demo useful and insightful, and I encourage you to run through it yourself in your own environment, but also maybe take it a step further by using your geospatial data and your creativity along with these LLMs to see what you can produce. Let me know how you get on in the comments below.